What's up, guys? In this video, I want to show you how to solve a system of linear equations using the elimination method. And we're going to do that by working through 5 different examples that I hand selected to help you through the process. I hope you enjoy. Okay, so now we're going to get into some problems with elimination. Now, when solving a system of equations by elimination, what we're going to do is we're going to either add or subtract the equations, and sometimes we're going to have to multiply by a multiplier. But to determine if we need to multiply by a multiplier, we know we can use elimination right off the bat. One, when we have the same variable with the same coefficients. Now, we could apply substitution on each one of these, but we're going to work on practicing elimination. So I would say elimination is nice when we see that they have the same variable, have the exact same coefficient, and it doesn't matter if they're both positive or both negative. But you can see both of my x's both have a coefficient of +1. Now, when they have the same coefficient with the same sign, then what I'll do is I'm going to subtract the two equations. All right, so when you have two equations with the same variable, have the same coefficient with the same sign, you subtract the equations. And I'll see why that works. 1x minus 1x is 0x. 0 times x is 0. So we say that our x is now eliminated. 2y minus y leaves us with y equals 10 minus 6 is going to equal 4. Therefore, now we know the value of 4, or the value of y, which is 4. So now to find the value of x, I need to choose one of my equations, the top or the bottom, to find the value of x. And it doesn't matter which one you choose. If I say x plus 2 times 4 equals 10, or if I say x plus 4 equals 6. It doesn't matter which one you use. So you can see that x is going to equal 2. It doesn't matter if you choose the top equation or the bottom equation, x is going to equal 2. Therefore, our solution is x equals 2 and y equals 4. And we can prove that by plugging in 2 in for x and 4 in for y and making sure that is true for both equations. Well, 2 plus 4 is equal to 6. 2 times 4 is 8, plus 2 is 10. So it works for both equations. So therefore, ladies and gentlemen, that is our solution by using elimination. Thanks. All right. Now, usually elimination, ladies and gentlemen, I prefer to use elimination when we do not have a variable with a coefficient of 1. In this case, you guys can see we have a variable with a coefficient of 1. So it would be pretty simple to go ahead and use substitution like I did the last problem, right? But let's say you have a grudge against substitution. You don't like doing substitution. So you could easily do substitution for this problem based on what we learned on the last example. But let's say you don't like using substitution. Let's say you want to know how to do elimination, or you prefer elimination. Well, the way to do elimination is basically what you're doing is you're going to be adding or subtracting the equations. All right? Now, let's just kind of look at this hypothetically. First of all, if I add these equations, I would get 4. You guys don't need to write this down. 4x minus y equals, what am I doing this? It would be negative 8. No, negative 26. What am I doing? No, negative 8. So when you guys add them up, do you have any of your variables, do they have a coefficient of 0? No. So therefore, neither of your variables are going to be eliminated. If we go ahead and subtract the two equations, I get 2x plus 5y minus 26. Again, are either of my variables eliminated? Yes?
Why is it plus 5y?
Because 2y minus a negative, double negative makes it add. Okay? Or again, do I have a 0 for my coefficients? No. So therefore, 0, because what you want to do is get 0 times a variable. Justin, put it away. 0 times a variable is going to eliminate your variable. So let's go through the steps. The first step is going to be align your variables. Okay? If you guys look up here, you guys can see that the variables are aligned. X is over the x, y is over the y. Some of the problems you might get, the variables are not aligned. So you're going to want to make sure that's the first thing you do. Okay? Step number 2. Use or identify variable with equal coefficients. Use multipliers if needed. Okay? So what I mean by that is, do either of my variables have coefficients that are exactly the same? Do x's have the same coefficient? No, that's a 3 and that's a 1. Do the y's have the same coefficient? No. Okay? So I don't have, either of my variables have the same coefficient. So therefore, what I'm going to have to do is apply a multiplier. And basically what I'm going to do is multiply one or both of the equations by a number so that they can therefore the coefficients can have equal coefficients. So basically what we want to look at is there a number that I can multiply by one of the equations that will give me equal coefficients? And if you guys look at this, what would happen if I multiplied this bottom equation by 3? What would this now turn into? 3x. So that's exactly what I'm going to do. I'm going to rewrite the top equation, and I'm just going to multiply the bottom equation by 3x. So therefore, I have 3x minus 9y equals 27. Do you guys see what I did there? So now, by multiplying this by 3, by applying distributive property, I now have produced two equations that have the same multiplier, or that they have the same coefficients. Sometimes it might not be easy. Sometimes you might have to multiply both equations by a multiplier to get the same number. All right? Now, I will give you guys a tip. I do not like having the coefficients being the same. I like to have one positive, one negative, so therefore I can add them. So rather than multiplying by positive 3, I would say multiply by negative 3, because that would make that negative, that positive, and that negative. Okay? So I always like to have my coefficients one positive, one negative. Why, you ask? Because I prefer to add my equations rather than subtract them. If you want to subtract, that's fine. But 3x minus 3x is going to be 0x. 0 times x is just going to be 0, which we're not going to have to include. 2y plus 9y is going to be 11y. And negative 17 plus negative 27 equals negative 44. Now, divide by 11. Y equals negative 4. So now I determined my y value. All right? So identify your variables. I guess I should do. So that was step number 2. 1. 3 is add, subtract equations. Add or subtract equations. So now I know what y equals negative 4 is. So now I need to find the value of x. So I can plug it into any one of my equations. You could plug it into this equation, that equation, this equation, that equation. It doesn't really matter. You're just going to want to pick an equation that's going to work for you. I'll choose this original equation to plug it in for. X minus 3y equals 9. Take y equals negative 4. X minus 3 times negative 4 equals 9. Negative 3 times negative 4 is going to be a positive 12 equals 9. Subtract 12, x equals negative 3. Now I have a solution of negative 3, negative 4. OK? So now we're going to go and take a look at elimination. Because if you guys look at this problem, I don't have any of my variables have a coefficient of 1, do they? So the solving for a variable and plugging it into the other equation is probably not going to be a good idea. So basically what we're going to do in elimination, basically what we're doing is we're trying to add or subtract our two equations to eliminate a variable, meaning we want to get the coefficients to be 0. So let's just kind of look at this, because we want to eliminate. Remember when I plugged one equation into the other, I had that equation with all y's? That's what we want to get. Now let's look at this. If I add these equations vertically, so the first thing you always want to do is make sure your variables and everything is aligned vertically. If I add these equations, I get 5y minus 9x equals negative 2. Did I get a 0 for a coefficient here? No, so I didn't eliminate a variable. So then we look at subtracting the 2. That's y. Negative 5 minus the negative is going to be negative x equals positive 2. Did I eliminate a variable? No. So when you're looking into doing elimination, what you want to do, sometimes you'll have the same coefficients. Sometimes you won't have the same coefficients. So what you want to do is obtain the same coefficients for one of your variables. So you want to find the coefficients that are going to have the smallest common multiple. So what do you think has the smallest common multiple? What is the smallest number that 3 and 2 both divide into?
1.
No, both divide 2 and 6, right? And 5 and 4, the smallest multiple for them would be 20. So I'm probably going to want to eliminate the y's. If you want to eliminate the x's, though, it's not wrong. You can easily do that. So you said the common multiple, the LCM, is equal to 6. So what I want to do is I want to both get these to be 6. So to do that, I need to multiply this equation by 2. I need to qualify this equation by 3. Does everybody see that?
Yeah.
OK, so now let's apply distributive property to everything. 2 times 3y is 6y. A minus 10x equals 0. 6y. Negative 12x equals negative 6. Does everybody see what I did?
Yes.
But now I have a systems of equation that my coefficients are the same. OK? Now, I'll give you guys a hint. To subtract to get this to be 0, am I going to have to add or subtract the equations? Subtract, right? However, I will tell you, a lot of students don't like doing subtraction. OK? So if I was to add these, that means one of these would have to be negative, right? So what I can do is just pretend, hey, why don't, instead of multiplying by 2, why don't I just multiply by negative 2? That would make that negative 6, that positive 10x, and then that would be a negative 0, which would still be 0. I prefer to multiply by negative, so I always have a positive negative, because I like adding rather than subtracting. And I think you guys would like that too. So therefore, now to get this to be 0, I'm just going to add. So negative 6y plus 6y is 0y, which is just 0. 10x plus negative 12x is a negative 2x. 0 plus negative 6 equals negative 6. You guys see? Now we have a pretty easy equation to solve for, right? X is now equal to 3. So now we know the value of x. And we still need to find the value of y, though. OK? So we need to take x, and we need to figure out which one of these equations. Again, it doesn't matter which equation. You can plug into these equations. You can plug in these equations. But these equations are smaller. So we need to solve for x. And so let's see. Emily, which equation would you prefer to plug it into, the top or the bottom?
Bottom.
OK. So I just take this equation. 2y minus 4x equals negative 2. I know x is equal to 3. So I say 2y minus 4 times 3 equals negative 2. 2y minus 12 equals negative 2. Add 12. Add 12. 10. 2. 2. Y equals 5. So now I know my value of x equals 3, and I know y equals 5. So therefore, I have my coordinate point, which is one solution, which is 3, 5. All right. So ladies and gentlemen, here we have a systems of equations. 1/2 x plus 1/3 y equals 7. And 1/5 x minus 2/3 y equals negative 2. Now again, when we're looking into applying this algebraically, a lot of times we're looking at applying eliminate or substitution if we have a coefficient of any of our variables equal to 1, which in this case we do not, right? So the next thing we want to look at is using elimination. And elimination basically is just adding or subtracting our two equations. And if we add or subtract these two equations, we want to be able to get a coefficient of 0. So if I add or subtract 1/2 x plus or minus or 1/5 x, am I going to get 0x? Does 1/2 plus 1/5 give you 0? Is 1/2 minus 1/5 give you 0? No. What about 1/3 and 2/3? Is 1/3 plus negative 2/3 going to give you 0? No. So they're not going to give us 0. So the next thing that I would recommend to do is get rid of your fractions. So to get rid of my fractions, nope. I want to get rid of, why are these, the reason why these are decimals is because 2 does not evenly go into 1. So you want to multiply it. So you want to get the numerator into a number that is evenly divisible by 2. Well, you also need to get into a number that is evenly divisible by 3. So what is the smallest number that 2 and 3 are divisible by? 6. So I'm going to multiply everything by 6. Now, same thing over here. We need to find a number that 5 is divisible into and 3 is divisible into. And that smallest number is? Then we apply distributive property.
You got all 3?
Yep, you have to do all 3. So 6 times 1/2 x is going to be 3x. 6 times 1/3 y is going to be 2y. 6 times 7 is equal to 42. Follow me? Then I do this one. 15 times 1/5 x is going to be 3x. 15 times negative 2/3, just multiply over. 15 times negative 2 is negative 30. 1 times 3 is 3, so negative 30 divided by 3 is negative 10. Follow me? Or you want me to show that? OK. 15 times negative 2 is equal to negative 30. Now, you can see now, not if I add them, but if I subtract these two equations, now I have them 0, right? Which is cool. However, I don't really like subtracting, and I don't think you would too. So rather than multiplying by 15, what would happen if we multiply by negative 15? Then that would be negative, that would be positive, and that would be positive, right? I think I would prefer adding negative numbers than subtracting. I think it's just easier for students. So let's look at what we have. 3x plus a negative 3x is 0x. Now that got eliminated. 2y plus 10y is 12y. And 42 plus 30 is going to be 72. Now I can solve for y. And that's going to be 6. OK, so now I know the value of 6. And then to plug that in, you could plug it into one of these equations if you like. Or you could plug it in one of these, which you probably would prefer, right? No fractions. So we know y is equal to y is equal to 6. Let's plug it in this one. 3x plus 2 times 6 equals 42. 2 times 6 is 12. Subtract 12. 3x equals 30. Divide by 3. Divide by 3. X equals 10. Done. OK, so now we're going to get into some problems with elimination. Now, when solving a system of equations by elimination, what we're going to do is we're going to either add or subtract the equations. And sometimes we're going to have to multiply by a multiplier. But to determine if we even need to multiply by a multiplier, we know we can use elimination right off the bat. One, when we have the same variable with the same coefficients. Now, we could apply substitution on each one of these, but we're going to work on practicing elimination. So I would say elimination is nice when we see that they have the same variable, have the exact same coefficient. And it doesn't matter if they're both positive or both negative. But you can see both of my x's both have a coefficient of positive 1. Now, when they have the same coefficient with the same sign, then what I'll do is I'm going to subtract the two equations. All right, so when you have two equations with the same variable, have the same coefficient with the same sign, you subtract the equations. And I'll see why that works. 1x minus 1x is 0x. 0 times x is 0. So we say that our x is now eliminated. 2y minus y leaves us with y equals 10 minus 6 is going to equal 4. Therefore, now we know the value of 4, or the value of y, which is 4. So now to find the value of x, I need to choose one of my equations, the top or the bottom, to find the value of x. And it doesn't matter which one you choose. If I say x plus 2 times 4 equals 10, or if I say x plus 4 equals 6. It doesn't matter which one you use. So you can see that x is going to equal 2. It doesn't matter if you choose the top equation or the bottom equation, x is going to equal 2. Therefore, our solution is x equals 2 and y equals 4. And we can prove that by plugging in 2 in for x and 4 in for y and making sure that is true for both equations. Well, 2 plus 4 is equal to 6. 2 times 4 is 8, plus 2 is 10, so it works for both equations. So therefore, ladies and gentlemen, that is our solution by using elimination. Thanks. Welcome, everybody. So what I want to do, first of all, we need to solve this by using elimination. And what I want to kind of do first is get rid of these fractions, because I absolutely cannot stand fractions. So why would I want to solve a problem that's going to have these 4 and 3 in the denominator? So to do that, I'm going to have to multiply by the LCD of 3 and 4. And the least common denominator that 3 and 4 both divide into is 12. So what I'm simply going to do is I'm going to multiply this whole equation by a multiplier of 12. And I multiply this by 12 and that expression by 12. Now when I multiply this expression by 12, I'm left with the 12, and that's going to cancel out to go to a 3. And when I multiply 12 over here, that 3 divides into 12 4 times. So therefore, I'm going to be left with a new equation that I can now apply distributive property for, which is going to be 3x. Oops, and also, I'm sorry, I got to multiply 12 over here as well. Yes, so therefore, I'm going to have 3x plus 9 plus 4y minus 4 equals 12. Then I can combine these two, so I have 3x plus 4y plus 5 equals 12. Then I only want to get the x and y's by itself, so I subtract 5, and my final equation is 3x plus 4y equals a positive 7. All right, so I did all that work to get to this new equation. Now let's go back to our two other equations. I have 2x minus y equals 12. Now, again, so pretty much all this work here is to get it into this format. So now, again, remember, when we're solving elimination, we got to get the variables to have the exact same coefficient. It doesn't matter if they're positive or negative. We got to have them the same coefficient. So rather than getting the 3 and 2 to the same, that means I'd have to multiply a multiplier on top and a multiplier on the bottom. If I just multiply this bottom equation by 4, then this will be positive 4, that will be negative 4, and I can use I can eliminate one of them. So what I'll do is I'll multiply the top equation, or the bottom equation, I'm sorry, by 4. And when I do that, I end up getting the top equation remains the same, 3x plus 4y equals 7. And the bottom equation now becomes 8x minus 4y equals 36. Okay, so that's what happens when I multiply 4 times the whole bottom. Now, I can simply, the process of elimination is once you have two terms that are exact, the coefficients are exactly the same, if one's positive, one's negative, then you can just add the two equations up. And by adding the two equations up, what that allows you to do, this gives me, then that eliminates that variable. So therefore, this is 11x equals 7 plus 36, which is going to be 43. Then I divide by 11, and x equals 43 over 11. Now I need to go ahead and solve for y. So to go ahead and solve for y, I'm going to take that variable and plug it back into my equation to solve. So I preferably am going to choose this equation to plug this in for. So I have 2 times 43 over 11 minus y equals 12. Well, this is really 2 over 1, so that becomes 86 over 11 minus y equals 12. Then I'll add the y, and I have 86 over 11 equals y plus 12. Subtract 12, subtract 12. And therefore, my final equation is y equals 86 over 11 minus 12. Now again, I still want to get them to have the common denominator, so therefore I'll multiply by 11 over 11. And therefore, I have y equals 86 minus 12 times 11 is going to be 132. And then 86, so that would be 46. So y equals a negative 46 over 11. So there you go, ladies and gentlemen, a little bit of fraction practice for you to help you go ahead and solve using elimination. Thanks.